Okay. Excuse me. Frog stuck in my throat. So, yeah, great. Now, what we were talking about was the load balancer, and okay. So, we were talking about what is Azure Load Balancer.
Everyone else is now muted.
Okay, so with Azure Load Balancer, you can scale your applications and create high availability for your services. Load Balancer supports inbound and outbound scenarios, provides low latency and high throughput, and scales up to millions of flows for all TCP and UDP applications. So what is it saying? So suppose you have two virtual machines here, and excuse me, those two virtual machines are actually having web server there, web server and web server. So those two web servers, suppose now the traffic is on one of the web server, and it is maybe light traffic, maybe 200 users there to a web server, and then all of a sudden there's huge traffic and it becomes 3,000 users, 5,000 users. That one machine might not take that kind of traffic. People are opening files, closing files, or it's a web server, so clicking the web pages back and forth to, suppose it's some product selling site, so they are just browsing the products there. It could be really there could be a lot of pressure on that web server. The CPU of that server, the RAM, wow, what a way. So RAM and the SSD disks. So they will have a lot of SSD will have a lot of IOPS. RAM will be also used as users are browsing the pages. But if there's a huge traffic there, in that case, it will be very difficult for one server to handle all kind of traffic. So ultimately what happens is the server just crashes, right? If there is too much traffic, so the server crashes, but or freezes, so it cannot take a lot of traffic then in that case. And that's where comes that requirement that how about we load balance the load of traffic on multiple servers. So if we go for suppose we create a load balancer here, so that load balancer normally with load balancer it comes a public IP or a DNS server as well. And so when the traffic is connecting now, so it will be first hitting the load balancer with some public IP there, and then it will be balancing that traffic among different servers here, right? So and you can add more servers here, and it will load balancer will just redirect the traffic to all those servers. So suppose you are really expecting a lot of traffic, so you can just keep on adding more servers and tell the load balancer that, hey, I have two more servers added here, so why don't you just balance this. So as soon as you add the servers to the load balancer, then it will simply excuse me, it will simply then balance the load between the 4 or 5 or 10 or 20 or 100 servers, right? So this is just what the topic say here. The load balancer supports inbound and outbound scenarios, provides low latency and high throughput, and scales up to millions of flows for all TCP and UDP applications. So it also scales up to millions of flows, which just means that Azure is claiming that if you were just anticipating 10,000 users or 20,000 users and 100,000, 500,000, even if there are millions of users connected, still it at least you would not, their backbone network is so good that you will not see that if huge traffic is there, that the traffic is dropping, the packets are dropping, and it is really not reaching those web servers. So that will not be the case in any way. If there, even if there are millions of users, you will be the users will be there. You just need to make sure that you have enough servers to handle millions of users or not, right? So if you go back to the slide here, there's load balancer excuse me, distributes load balancer distributes new inbound flows that arrive on the load balancer's front end to backend pool instances according to rules and health probes. So this is what we're going to actually configure, that load balancer distributes new inbound flows. So inbound, whatever traffic is coming from outside to inside, that arrive on the load balancer's front end, and that is the load balancer itself, to backend pool instances. That is those those machines that I created in the diagram. So those are called backend pool instances. Those machines that will actually get the distributed traffic from the load balancer. So they are called backend pool instances according to rules and health probes. So whatever rules we create there, and health probes, definitely that's very important, that which machine is up, it will send the traffic to. If the machine is down, it won't send the traffic to that machine. So okay, allowing, yeah. So what we're trying to say here is that the load balancer will need there's a terminology that is being used to configure load balancing here, and backend pool instances are all the machines that are getting the traffic, and according to rules and health probes. So if we go ahead, Azure Load Balancer is available in two SKUs, or this is just to SKUs just means that you have in inventory how many machines there, 1 2 3 4 5 6. So this is going to attach it to the inventory, how many machines are there. So two SKUs there, and that is basic and standard. There are differences in scale, features, and pricing. So we're going to be going for standard load balancer there. Any scenario that's possible with basic load balancer can also be created with standard load balancer, although the approaches might differ slightly. So we're going to be creating a standard load balancer, and let's check out. But why use load balancer? You can use load balancer to load balance incoming internet traffic to your VMs. This configuration is known as public load balancer. So you can also use load balance traffic across VMs inside a virtual network. So if you create a VNet, we will be creating later a VNet as well. We will be creating subnets. We will be creating also route tables, and then peering as well. So you can also reach a load balancer front end from an on-premises network in a hybrid scenario. Both scenarios use a configuration that is known as internet load balancer. So what I created there as a diagram, so this can be internet traffic as well, so coming from internet, or this can be, suppose you create your own private zone there, or that is called VNet. You create your own private VNet there, and there are machines inside that VNet. You can just use this load balancer. So the traffic will be first hitting the load balancer, and then it will hit your VNet, and then the machines, it will be distributing the traffic to the virtual machines inside the VNet or virtual network, which is just a private network in the public cloud. So if we are excuse me, so port forward traffic to a specific port on specific VMs with inbound network address translation NAT rules. You can also create a NAT in that traffic. So suppose there is that VNet that you have created here, and that VNet is you're having some machines, VMs with private IPs. So VNet with private IPs, And in that case, you can also have NAT configured here. So these machines which are configured in private IPs, obviously they cannot have internet connection. So the traffic that is coming from outside here will be hitting the NAT, and through port forwarding, the traffic could be actually sent to these machines. So you can use port forwarding as well, and forward a specific traffic. Port forwarding, you can just connect from your home or from your office to your home PC. If you go inside the DSL router that you have at home and do the port forwarding, which just means that you can define what kind of traffic. Suppose it is port 25, which is SMTP traffic, and then you define that is it TCP / UDP, whichever port is that, and then you have to define the IP of your home machine. IP of your home machine. So normally people use it for actually port 3389, which is RDP. So suppose you want to connect to your home PC with the port 3389 RDP, and then so this can be just achieved by port forwarding. So that's just an idea about that what you have to configure. But the thing is that specific type of protocol can be configured to reach a specific machine. That is done, and you can do that with load balancer and NAT protocol, which just basically provides internet connection to private IPs. So you can do that with load balancer as well, and provide outbound connectivity for VMs inside your virtual network by using a public load balancer. So it is normally used for inbound traffic, but you can also use it for outbound traffic as well. So normally the traffic is just inbound, right? Oops, that's a wrong error. And it is inbound, right? But it can be traffic for outbound as well. And so if the traffic is going there, that can also be balanced to outside resources. Suppose you want that traffic to actually reach some other branches. This is suppose, okay, again, wrong one. So suppose you're selecting a Toronto branch, and you're selecting Singapore branch, and you have here so suppose this is Tor, this is NY, the New York branch, and this is Singapore. So in that case, you can put the outbound traffic and actually send it to these destinations as well. So outbound load balancing can also be done with that. So let's try to actually do that now. And we want to create configuring load balancer. So there's a link down here that is showing step by step how to do that load balancer, how to configure load balancer and load balancer traffic between the virtual machines there. So configuring load balancer, and then that is source IP, source port, destination IP, destination port protocol. So load balancer does balance the traffic according to whatever machine it is sending the traffic to you. Now there's private IP port, private IP port. So these are the machines to which this load balancer is sending traffic. So we need to pretty much create that. Now this is the link that really gives you the steps there to balance the traffic there. I'll just put it there as well in the chat. And if I just open that, so it is not only showing that what is load balancer, but all the information, the diagram, port forwarding, and there is then detail of all what you can configure. But let's just try to configure that load balancer now, and I'll be configuring that. And public load balancer, internal load balancer, you can have that figure as well, where you can have load balancer first coming from internet to your virtual machines, and then this is called a web tier, and then this is database tier. So you can create a load balancer whichever traffic is coming to the virtual machines can so whatever changes were made and need to be sent to the databases, then again another load balancer will just send that traffic from virtual machines, front-end virtual machines, to the back-end databases there, where end users are not supposed to connect, right? So that would be another scenario where you can use load balancers in multiple tiers there, right? So I'll just add that here. So and that would be multi-tier. In that case, the load balancer can be used on 2 tiers, right? Okay, so what we were talking about, how to configure the load balancer, and for that there is a lab that Microsoft has given step-by-step instructions on how to do that. I'm just putting that in the chat as well, and that is also oh, okay, there is. So this is in the chat as well. I've just put that. Oh, yeah. So now what we are trying to do is, let's just follow that lab which I just put in the chat, and in the WhatsApp, and also I think, yeah, in the chat I already put that. Okay, so now I'm just gonna try to configure the whole lab here, and then we're going to and I'm going to explain that as well, how to really go ahead with configuration. While I'm doing the configuration, I'll just explain the steps as well. Yikes. Oh, okay. Okay, so the first the steps here are I'll just what I'm interested in seeing is this. And I'm just going to go to that Azure, and let's create some virtual machines. But first of all, we're going to create the load balancer itself, and and after that, once we create a load balancer, then create load balancer resources there, and then there's a backend pool that we need to configure. Backend pool just needs to have multiple machines there, and then create a health probe that will actually probe those virtual machines, or make sure that the virtual machines are actually available there. So now those virtual machines need to be created. So we're going to be creating actually 3 virtual machines there, and we're going to be placing them behind that load balancer. So let's do that now. So I'm just going to be creating the virtual machines but before that, actually let's follow that document link that I've given you, because just written steps won't really help us understand that. We have to actually do that to understand. So it create a standard load balancer. Let's do that first. And how to do that, I'm just going to go to that Azure screen here. There it is. So in the Azure screen, I'll just okay, I was in the process of doing that. Okay, so I'm in this area of Azure. So I'm on the portal, and this is where I'm configuring that load balancer. So the first step would be to create a load balancer. So I'm just gonna go to create a resource on the left side here, although load balancer is actually written here as well. So load balancer we can just create from here as well. So I'm just gonna click that load balancer on the left side, and this screen comes where there is no load balancer right now. So I'm just gonna click the add button here to create a load balancer, and then it asks for the name there. First of all, it is I'm just going to create a resource group, so I could delete that at the end of the lab. So I'll click the create new, and then it's the today's date, 28 2019, and RG. So resource group here 2019 29 October 28 sorry 28 October 2019, and I'll press OK here. Then there is that resource group is created. Then we can just actually give the name there, and that is the test test dash load balancer. test dash load balancer, and then there is that here, what is the type here? You can use internal load balancer to balance traffic from private IP address. Public load balancers can balance traffic originating from public IP addresses. So obviously we're going to keep it public because we're going to be testing it with internet traffic. And then what type of, choose a standard load balancer for up to 1000 instances and greater backend pool flexibility, high availability ports or HA ports, and zonal and zone redundant scenarios. So that is where standard load balancer comes. Basic would not be of any for a bigger environment, basic would not be good. So I'm just gonna click here, learn more here, and that just shows, which I already actually placed the icon there, URL there, and that just shows that how load balancer will really work. So that's the same that I already put there. Now I'm just going to click the standard here because we're going to create a standard load balancer, and then we're going down to the public IP address. So I'm just going to put test dash public. Well, I'll just go for my name here. Your first name dash public IP, and I'll just keep the naming convention similar. Your first name dash load balancer, and so what we are trying to go ahead with is once the public IP is defined, the load balancer is defined, and then we can actually go for next. It used to give the available oh, okay, one more thing, Canada East is there, right? So I would just want to go for US East, East US. It is known to have more features and than Canada East, but when I still select that US East, or if I just go for US East 2, it's not showing. Oh, it is showing availability. See this availability zone? I was just looking for that, this one, right? So if I just select, yeah, it was there all this time, but if I go for again Canada, that was it, right? So when I go to Canada East, availability zone feature is not there, which is that the load balancer will be available across the availability zone, right? Too. So if I go to US East, then now see availability zone feature is there. So they did not put that feature in Canada region, so they might not have a lot of clients from there. That is strange. So anyway, availability zone feature is there, and so I'm just going to go for select. We're going to go for zone redundant here, and that is zone redundant. So if you select that, so whichever zone you create the virtual machines in. Yeah, Zaka, I'm not sure why it started with Canada East. It would be, the main thing would be that normally it just checks that where we are, and otherwise I never chose this myself when I logged in. The last service I did chose, I think it was already chosen Canada, so I just didn't use that, so it keeps on using. So first time when you log in, you can just choose your region, and then but there's no guarantee that it's going to always log in from that region. We just have to see according to the services which region you are selecting there. Yeah, so this is exam lab question as well. Okay, so the whole load balancer, Jatinder, the this whole lab came. I mean, like, oh, okay, availability set. Ah, so yeah, availability set is what we did in virtual machines. And last class we were doing that, we did that. Now this is availability zone, which is actually others other than availability set, as you're right. So either you select this availability set or availability zone. So now, okay guys, what we are putting here is on redundant, but if we are in Canada, obviously it will just connect us automatically to the nearest region, and that is Canada East. We are inside actually Canada East, or in that region. So now that, but they don't have advanced features there, so that's really sad, bad. Okay, whatever. So now USE is there and zone redundant. So let's just click that zone redundant here and allow. So cost to be minimized. So basic SKU does not have advanced features within there. Only standard SKU would scale to millions of connections there, and it will be zone redundant. Basic SKU will just be totally basic within one availability zone. So that is not recommended. In fact, this availability zone is there. If I just click that basic, that availability zone feature is gone now, right? If I click standard, now availability zone feature is there. So basic would be too basic actually for any company. So better go for standard, and you should be highly available. Definitely, it's for large companies. It's not for small companies. Small companies can go for basic with because they will have their virtual machines in one region and one availability zone. And I don't see availability zone regardless of region. I will try and figure this out. Oh, okay, Zaka, you're following. So regardless of region, you're not seeing that. That's gonna be strange. So you can just close this whole page and then come back again. And when you're putting that load balancer name there and resource group, then just put that. So first time it was not coming to me as well. I had to just close the page, refresh it, and then come back, and it was there. Okay. Okay. Let's try to go ahead and create new there, and public IP address name is this, and then availability zone is zone redundant. We're not giving any specific zone that we're going to be creating that. It is zone redundant just means that if the virtual machines that we're about to create are on zone 1, virtual machines in zone 1, second is in zone 2, third is in zone 3, so it is zone redundant. It will still distribute traffic to virtual machines in all 3 zones. So that's it's better to just put it on zone redundant. And then let's click next, because not much there on this page of the load balancer. So I'm just going to click next, and then it's just that name, and so if you go for department, and sales, and then there is review plus create. So that's pretty much so on that page, review plus create. So we're just reviewing, not much here. So I'm just going to click create here. So after selecting the resource group, region, and the availability feature, then we're just good. Let's go ahead and click create. So first the load balancer gets created, and then we can go for backend address pool, health probe, and specify load balancer rule. And once it is created, then I'm just going to go to the bell icon there, this one, and see that deployment is in progress. Okay, it seems like it's still creating. Okay, because there will be more options coming there once you do that. Oh wow, what is that? Network Watcher is a regional service that enables you to monitor and diagnose conditions at a network scenario level. Oh, okay. So these were the questions that came to you. Okay, thanks, Jitendra. Enables you to monitor and diagnose conditions at a network scenario level. 5 tuple, source IP, source port, destination IP, destination port, protocol type, network watcher, connection monitor. Oh, okay, that's the same thing again and again. Okay, the security group decision and the name of the rule that denied. Well, yeah. Okay, that's good. Good to know. Next hop provide. So that was, I think, from this page. Watcher. Nope. but network watcher related questions came, right? Okay. So okay guys, oh well, it is done for me, and I'm just gonna close that and go to the resource. I'm gonna click the home button here. Load balancer Azure services is showing here, so I'm gonna go to the load balancer. There's my load balancer that got created in East US, and then I'm just gonna click load balancer here. So then there are all these options there that we need to configure in order to actually see that load balancer get configured, and actually we need to test it, put it to test as well. So first of all, when we have created the load balancer, we can just go for a backend address pool. So there is a backend pool here, and there is health probes here. There are load balancing rules here, inbound NAT rules, properties, logs, and export template. Then there are alerts. So and front end IP configuration, and what we can do, there is my load balancer under settings and then backend pool. So we're just going to go for backend pools here, and backend pool, we can just create a backend pool and then backend pool instances. So what will be there in the backend or in the back of the load balancer? In this messy diagram here, so this area behind the load balancer, what kind of how many number of machines are there that are in the back end pool. So these are called backend pool instances. But so first we're defining the backend pool itself. So I'm just going to click go to the backend pools here and click add. So it's a bit more, it has more steps to configure as compared to the AWS's Amazon Web Services load balancer. But yes, whatever steps they require, we just have to have those steps done. And then I'm just gonna put that your first name back and pool, right? And back and pool. IPv4 is there. Virtual network, obviously, this is something we haven't just created any of our own VNet. Later, we're going to be creating those VNet as well, VNet or one VNet as well. And then on the Bagel page, we're just typing the name there, and then that's it. So virtual machines will be added later to the backend pool with an IP address, but that's it. We just give a name there, and we're going to just click the add button here. So once we click the add button, so a backend pool is defined here, but we don't have the machines created yet. So once we do add the machines, then we're going to add the machines. During the addition of the machines, it will ask, hey, which backend pool you want to be part of, and we're going to say your first name dash backend pool, or the one that we created here, which is part of this load balancer here. So we create a backend pool. Then there is a health probe that we need to create, and that is health probe is, if we go there, this one, to allow the load balancer to monitor the status of your app. So this is just separate time. And okay, so what we were talking about is, and that once we are connected to the backend pool or the health probes there, health probe is simply, it's not it's the most, one of the most important thing. Health probe will make sure that which of the machines, if we go back to the diagram here, that health probe will keep on sending packet to each machine. Are you live? Are you live? Are you live? Are you live? And if one machine does not send a response, so it responds there, so it will, health probe will tell the load balancer, hey load balancer, I am not receiving a response from here. I'm not receiving back any packets there, so can you just stop sending all the traffic what you are distributing among the machines, and just send it to this and this machine, but not to this machine, right? So health probe is very, very important. It will just check that which machine is healthy or is reachable, and which machine is not reachable. So we're going to, so we have health probe. Let's just try to configure that. And So we're going to go for health probe and click the add button. So let's click the add button here and set some configurations here for the health probe. Once you click the add button here, so your first name dash health probe, and then there are some configurations there. So the name is my probe, and then protocol is TCP, but we can go for HTTP because we're going to be creating web servers, and we're going to be configuring the first page of the web server just to see that if it shows that first page or not when we load balance, and then it should show the second page or the third page or the fourth page, right? So and then port 80 is okay because it's HTTP. If it was supposed to be HTTPS, then you would just choose the port. Suppose I go for HTTPS, then port will be 443. But then make sure that you have the certificate also purchased from maybe from GoDaddy.com or some other site, and map it or bind it to the name of the load balancer. Now I have the HTTP site, HTTP protocol selected here and port 80, and then the path is there. Now path is there if any one of you have ever installed a web server and then try to actually put a path there. So normally what happens is that in the web server, the C drive of the web server, we basically have inetpub folder. So this folder gets created as soon as you install the web server or IIS server. A folder called inetpub gets created, and inside that folder is www, and inside that is the index.html file, and that file is the first page. It's our HTML. That's the first HTML page. Suppose a welcome page or all the links are there. So normally what happens is the health probe tries to send the packet to the machine, and it tries to check that if it can access this folder or reach this folder. If that it cannot reach that folder, then it will send the tell the load balancer not to send the traffic to this. If obviously it cannot reach this folder, this means it cannot reach the machine as well. So that's why there's a path here. It says that you need to give a path. You could so otherwise it is by default understood that this is the web server folder to which it needs to access. If it's not there, it's not gonna send the traffic there, because it is known that the web page or web server first file is normally in this path inside this folder and subfolder inetpub and www root. Actually, it's not www, it's www root, ROOT. Okay, so this is that's why this path is showing there. And interval, so that is how much the amount of time between probe attempts. So after every 5 seconds it's going to check, are you live, are you live, are you live, are you live. So and then there is that unhealthy threshold, so the number of consecutive probe failures that must occur before a virtual machine is considered unhealthy. So after two consecutive failures of the probe, which is after 10 seconds, it will determine, oh, I cannot reach that folder for 10 seconds. Okay, this means I'm now officially announcing that this machine is not available, and I'm not so it will just inform, I consider it as unhealthy, which means it is not available, which means load balancer, please do not send traffic to this machine. So unhealthy threshold is just two consecutive failures are okay to for it to enough for it to tell the load balancer not to send the traffic to that particular virtual machine. So we understand this configuration here, and that is actually 5 seconds is too much traffic. You can just change it to 10 seconds or 15 seconds or 20 seconds as well, just to check that are you live, are you live, if it's sending the machine. But we're gonna keep it to 5 seconds, so as soon as possible it could just check if keep on checking if our machines are live to see the results right away, right? So we're just gonna press OK here, and then go ahead. So I'm just gonna press OK. So we have defined a backend pool. We just gave a name there to the backend pool, and then we have defined a health probe, and that is every 5 seconds send the packets to the virtual machine. Every 5 seconds it is checking, are you alive, are you alive, are you alive, are you alive, right? And if two consecutive are you alive packets sending are failed, then this means that the machine is unhealthy, and it's going to tell the load balancer not to send the traffic to that machine. So okay, so if we go back here, backend pools are defined, health probes are defined, and then create a load balancer rule. So now we're going to go for a rule. So we define the backend pool, we define the health probe, then we go for load balancing rules there, and let's check it out what we need to configure there. A load balancer rule is used to define how traffic is distributed to the VMs. You define the front end IP configuration for the incoming traffic and the backend IP pool to receive the traffic, along with the required source and destination port. So we're gonna do that now. Let's just check and explore the rules here and configure them. So I'm just gonna click the add here, and then there is your first name dash load balancer rule, and then once we put the load balancer rule there, so then we're going to just define first of all where is the traffic coming. So what is the front end IP, which is just the public IP that will be given to the load balancer. And load balancer rules, and then the name is there, then the IP, front end IP is there, port is 80, backend port is 80 as well, and then my backend pool is already defined there. In the backend pool we're going to be actually fixing the virtual machines. And the health probe, is there a health probe? Yes, there is a health probe there. Okay, so Jatinder says that session persistence is important. Oh, that was an exam question as well. Wow. Okay, so definitely the session persistence when we are talking about that. So now this is also added here, and that is session persistence specifies that traffic from a client should be handled by the same virtual machine in the backend pool for the duration of a session. So none specifies that successive requests from the same client may be handled by any virtual machine. So the client IP specifies that successive requests from the same client IP address will be handled by the same virtual machine. Client IP and protocol specifies that successive requests from the same client IP address and protocol combination will be handled by the same virtual machine. So if we go for session persistence here, so that is client IP. So you want an end user who is connecting that. So if you go back to the diagram here, suppose there is a end user sitting in Toronto branch, and user, and is trying to make a connection to that load balancer. So the user makes a connection to the load balancer. After that, is the user going to be connected? Suppose a load balancer sends it to one of the web servers, and suppose this is the web server, or this is the web server. So after that, if the end user connects again, it's not about again, it's the attempt the user has taken, and the load balancer will make sure that this machine keeps the user connected here, and this machine should be giving the service to the user. Now there is a client IP, and that setting is that client IP. If we go for client IP there, so this machine will just check that what is the IP of that user, or IP and protocol, which is the second configuration here, and that is IP and protocol. And in that case, it means that IP plus what is the protocol. Suppose it is the SMTP protocol. Suppose this is the port 8044, like HTTPS protocol, or it could be any other protocol where you really need the session to be persistently connected there for the user, and same machine is giving the service to that user. So that's when cookies come into picture. Is client come from same IP, it will go to the that same server. Exactly. So Jatinder has said that. So definitely, if the this information about the end user has to be placed there for the web server in the backend to recognize it. Oh, okay, this is the guy again, this is the end user again that is connecting. Okay, I'll be keeping that session alive, and I'll be serving that client. So definitely, if you want that session persistence, then this is going to be used. Otherwise, we can just click none, and any virtual machine for that particular client can give service to that. So it's up to you. If you don't want the client to be staying long there, or you know that your application is not actually letting the client stay much longer, just connect and click and check that, and then go to next page. So in that case, you don't need that session persistence. Otherwise, definitely, if the client is going to stick to that service on the web server for a longer time, so that one client machine should be in the backend pool should be really connecting, serving that user. So then there is idle timeout here, and idle timeout is keep a TCP or HTTP connection open without relying on clients to send keep alive messages. So Zakai is saying that for performance, I would imagine session persistence could be issue. Well, the thing is that if the traffic is huge first of all, and there is a lot of traffic, users are actually connecting and not going to stay there. There are no services to keep connected there. Suppose the users are connected and then they are making changes there. They want to open files, close files. Suppose it's a lot of file servers there, so they will just stay connected there and check that. Suppose it's a SharePoint server in the background and they are opening, downloading files. So one of the SharePoint servers should be serving one user, second user, third user, fourth user. So if that's just a site where they are doing window shopping, or actually they are going to go for checking the all the products there, so then they don't really need to have that session persistence. Definitely performance will be then an issue if there are thousands, hundreds of users are connected to one machine and the second machine. The machines in the back end should be very good in hardware, so they can take that kind of users for longer time. So it will be, performance will be okay if the users are actually connected for longer time, if the machines are powerful enough. And well, there is a Jatinder saying to boost performance, a backend server might cache data that a user has requested, as well as pre-cache additional information it thinks a user might request. So, Jatinder, yeah, that is also okay. That normally that when there are backend pools, backend servers, when there are a lot of those machines, yes, if the machine is really saving cookies that this user connected, if it starts saving data as well, that would normally what happens is the machine does not save the data locally. It is a map. Suppose that's another server, file server. So file server, shared folders are actually mapped there in the profile of the user when the user connects, and whatever file the user saves is saved actually on a file server remotely, and that mapped folder is connected. Suppose next time after a long time user is connecting and the user is actually sent to another file server here. So in that case, the shared folder or the Z drive will be with the user in that server as well. But if those web servers are saving files locally, then obviously we have to really maintain them, because load balancer is there for large traffic, and if large amount of users are saving local, that would be difficult. So normally it is always Z drive, or a remote folder that actually is mapped to the user's profile when the user connects to any of the machine. So but yes, it depends on how the configuration was done by the administrator, that they can save the file. And if those are public files that any user will use, they're not particular user related files, then it is okay. Otherwise, every user is supposed to have their own file and its privacy. So sticky notes, routes, yeah. Sticky routes are just like static routes, or they are fixed routes for all the users to wherever the traffic is going, that traffic has to go from that particular one network to that particular other network. So suppose you are using that now in load balancer normally, well, that would be no, it should not be. Load balancer, you can try to have that traffic coming from only one branch. Suppose there are branches New York and Singapore, but you want the traffic to be coming only from Toronto branch. So that is also IP filtering. It is not about sticky routes there. So advanced load balancer may have it, but this one no. It should not have it unless they've added it in last few weeks. But it's not supposed to be related to sticky routes, and it's not supposed to be related to load balancer, unless maybe F5 load balancer, which is very expensive. Barracuda load balancer, they're expensive. So if you've seen that in context of load balancer, then let me know. Otherwise no, it's not related to that. And you don't really need sticky routes or for load balancer unless they have added that feature in standard. No, we don't need that, or we don't use that. So, okay guys, we're just trying to check here idle timeout, and idle timeout is keep a TCP or HTTP connection open without relying on clients to send keep alive messages. So how long do you want the user to the session to be there until if the user is idle? So 4 minutes if user is not doing anything, you want to cut the session, or you want to cut the connection, or maybe 10 minutes. How many maximum minutes we can go for there? That if I go for 1000 here, it just goes to 30 minutes. So the 30 minutes would be half hour you are allowing the user to stay idle, and then it will cut the connection. So depends on you. The default setting is 4, which is okay. But if user connection is idle and user is not doing anything for 4 minutes, it will just cut the connection. But it's up to you. How many users are you expecting there? And if you're thousands of users and it's just a product selling site, then you can just keep the connection idle time if they're not moving or doing anything. Suppose you went for session persistence there, so then give them some idle time, more idle time there, because users are maybe working and they're working on your local machine, then they are actually doing something over this connection. So give them a little more time to switch between their local environment, work environment, and the working on these web servers. So otherwise, lesser time for huge traffic without session persistence is okay. Okay, then there is floating IP or direct server return, and that is we recommend using this feature only when configuring a SQL always on availability group listener. It can be enabled only when creating a rule and if the port and backend port match. So floating IP normally is, or what is a SQL always on feature? Always on feature just is a high availability feature for the databases. And suppose there are SQL servers here, and so those SQL servers have databases inside, and these databases are having their copies, maybe one copy in one SQL server, and then you have another SQL server and another copy here. So copy of the database is here as well here. So that is the active copy. That could be the passive copy here. And when active goes down, then the passive becomes active. So the SQL servers really are so floating IP is just that if the users were connecting to now active copy. What does active copy do? It receives end user connections. What does passive copy do? It copies everything that has been happening, that all the changes that has been happening to the active copy. Active database copy, whatever changes are made are copied, synchronously replicated to passive databases there. So this is what active copy does. So floating IP just means that the users have to connect through some kind of public IP, right? So that IP is there. As soon as this machine, this SQL server goes down, it is not available, that IP, same IP is available on the other SQL server that has now become active, because the first one crashed, the second one became active, which was passive before or standby before. Now it is active. So the IP will still remain the same. It will just be available for this machine in front of this machine. And suppose this is also down and this third copy is actually active now, so the IP will be just available to this as well. This is called Elastic IP in AWS, and it is just floating IP here in Azure. So this so we can just disable it, but if we have a high availability features for SQL server, then we can enable it. So we can keep it disabled. So what we're doing here is add load balancing rule here, and then there is a front end IP, public IP already defined here. It is a TCP protocol that we're using, and then there is port 80 there defined as front end port and back end port. So front end also just HTTP traffic we're expecting, back end servers are also expecting HTTP traffic, and then health probe and backend pool, what we have defined there are, and then the session persistence is not is something that it's up to you. You want you have users that's going to be staying and using the services offered by your backend servers, then session persistence should be there. Otherwise, and how long do you want the idle time to be? If the users will stay there and is working for productivity, they ask that, hey, let our session not be disconnected so soon, and keep it there even if there's idle time there. Or and also if you have high availability servers configured with the servers, then you use floating IP. If active server goes down, then the passive server becomes active, or standby server becomes active, and the floating IP or IP is just attached dynamically to the new active server. So these are all the areas and configurations that we have gone through. The main thing is, do we understand what we're doing? And let's press OK here. And then now we need to create backend servers. So within the load balancer, we have configured backend pools, which is it doesn't have any servers or virtual machines yet. This is what we are about to create now. Then we configured the health probes. Then we configured the load balancing rules. Now what we need to do is that we need to create the virtual machines. And we're going to create 3 virtual machines, and we're going to be configuring IAS inside those 3 virtual machines, right? So and because it is this load balancer is zone redundant, so we can actually create virtual machines in different zones, and it should still be able to load balance those virtual machines there, right? So what we can do is I'm just gonna keep this page open. I'm gonna duplicate this page, and I'm gonna go to the virtual machine section there. So here I'll just simply go for all the portal menu, and then go down to the virtual machines, and in that I'm just gonna click the add button for the virtual machine, and I'm just gonna create first virtual machine, second and third. But we have to be very careful now when we are creating the virtual machines that uh, uh, so backend servers create virtual. Oh, we haven't actually created virtual network yet. So to have the load balancer test load balancer. So create backend servers. We're gonna do that and create a virtual network first. In fact, that is a VNet that we are creating specifically, so we can just put the virtual machines there, and then we can just go ahead and try to create the virtual machines as well. So I went to virtual machines directly, but we can actually first create a VNet, and VNet is just our private virtual network, right? So I'm just gonna go out of this, and then go to VNet, or which is virtual networks here, and I'll create the machine after that. So this is virtual network. So if we go for our diagram here, so we are just defining in that messy diagram that hey, all our setup is our load balancer is, and all our, especially our virtual machines are in that VNet, specific VNet, that or virtual network. This is called VPC in AWS, Amazon Web Services, and this is called so it is just a private network on a public cloud. It is just a private network on a public cloud. You can have virtual machines with public IPs there. Okay, so we get the idea that okay, this is a VNet, and the load balancer needs to know that, oh, all the virtual machines are inside a VNet or a private network that has been created in that public Azure cloud. So I'm just going to go back here and create that virtual networks and click the add button. Once you click the add button here, so we can just go for your first name dash my VNet, your first name dash VNet actually, and then we can just give some range there, and that is 10 dot we can just give 10.1.0.0, could be 10.0.0.1, and then /16, so 1 million IP addresses can come there. And we're not going for IPv6, and subscription is pay as you go for me. Resource group is, I have already created that for 28. Oh, there's 21 still there. Okay, that's bad news for me. I've just added another one. Oh, another connection here, and there's the resource groups created there, and there's that. I'm gonna select that. In fact, I'm gonna go inside that resource group. This is an old resource group. You can ignore that. What I'm doing. Oh, there's a vault here. Seriously, that is a problemo. Normally we are supposed to delete the resource groups when we are done with the lab, so we should not be charged, but looks like it's gonna give an error. Okay, anyway, resource group. Anyway, so I'm just gonna go back to this. Now there is that 28 Octo, so, and US East US here, and then the subnet name is default subnet name here, and you know, my backend subnet, we can just name it that as well. I'm just gonna name it your first name dash subnet, and then we can just give address range. So we're defining one IP address here as well for IP range. So we can use same resource group for VNet and load balancer. Yes, Ahmed, we can use the same resource group. And why are we using the same resource group for both? Because then when we delete that resource group, all the resources that we attach today, so we attach the VNet to the resource group, we attach the, we're about to create 3 virtual machines, we're going to be attaching those 3 virtual machines to this same resource group and the load balancer. So once you delete the resource group, everything attached to it will be deleted as well. So I'm just going for the IP there, 10.1.0.0 /24, and that is the range. So above there was /16, and then there is that you know, /24, and that is not 1 million addresses. This is 65,000 addresses. Okay, anyway, so now here then it is just offering that protection of DDoS or dynamic denial of service attacks. So it's just saying that, hey, don't worry about the DNS traffic protection. We are protecting your DNS traffic. So with denial of service attacks, from denial of service attacks. Service endpoints is enable one or more service endpoints for this subnet. Right now we don't have any endpoint or any machine, any server, any network that it's connecting to. It is just this that it is connecting to. It is just connected to this VNet here. Firewall, and that is obviously, if you want, Azure Firewall is a managed cloud-based network security service that protects your Azure virtual network resources. So obviously, if you want your VNet to be firewall protected, it can allow block traffic. So you will see that here. So let's just click that. So I'm not enabling the firewall. I'm not enabling the service endpoints. We don't need that right now. And let's click create. So we've created a VNet here, and that virtual net, we can just choose all the resources to be available for that virtual net or VNet. So it is still actually getting created here. So while it is creating, we can just go ahead and start creating virtual machines there. So your first name VM1, your first name VM2, your first name VM3 here. And if I refresh there now, refresh again and refresh again. Are you kidding me? Hey. Okay, deployment succeeded. Microsoft Virtual Network services was successful. Okay, go to the resource. Yeah, it is created. Okay, anyway, so I'm just gonna go to the virtual machines now, because after VNet is created, then I'm gonna create a virtual machine, or actually 3 virtual machines there, and we're gonna put them in the proper backend pool. We're gonna put them in the proper load balancer. We're gonna put them to the proper VNet. So we're gonna do all that with virtual machines. Then obviously we have to just make sure that they are connected to all the resources that we've already created there. So let's go ahead and create the first virtual machine. I'm going to click the add button here and virtual machine number 1, and I'm just attaching it to the same resource group, so I could delete it as well. Just with the same this resource group, when this gets deleted, everything else connected to that will be deleted as well. That's exactly what I want. So your first name dash VM01, then I'm going to go for your first name VM02 and your first name VM03. It is now in the region of East US, and availability zone, because we made the that load balancer zone redundant, so we can actually choose the availability zone, and then we can in fact choose this machine on zone 1, right? So this is a good way to check that is the load balancer zone redundant, because the second machine I'm going to attach it to zone 2, right? And third machine I'm going to attach it to zone 3, and they are all on different availability zone in East US region, and still the load balancer is supposed to send traffic to all 3 machines. So then images there, and I'll just go for the Windows 2012 or 2016. Okay, 2016, and then yes, the size is 1 vGPU, 3.5 GB RAM, and I'll just put my first name admin, and the password small abc, capital ABC, shift 123, and simple 123. Small abc, capital ABC, shift 123, and simple 123. I hope it is accepted. So Jatinder, we're going for availability zone. Availability options, there is availability set, but this is zone, the load balancers. So if I go to load balancer, and there we selected zone redundant, right? So we need to check that feature if zone redundancy is working for it or not. In fact, if I go to front end IP, and where's that overview? Okay, if I go to overview, so we configured there zone redundancy, so that's why we're putting it in different zones, just to check that feature. And backend pool, health probe, load balancing, yeah, public, okay, we configured it, and it's actually not showing backend load balancing rules, but that is, and probably, hey, where's that? It's supposed to show me, but zone redundancy is what we configured there, so that's why we're checking that. Okay. Properties, wasn't it? Did I not go there? Yeah, it should be here. Provisioning state succeeded, SKU is standard, resource location is East US, resource group, subscription name, nope. Zone redundancy is what we selected when we created the load balancer. So okay, that is weird, but normally it does show there. If I go for inbound rules, we didn't even create the NAT, so we don't really have to check that. Okay, so but it is for redundancy I'm going for. And availability zone, Jitendra, is a bit more useful than availability set. Availability set is within one region's one zone. Availability set is within one region's one zone. Availability zone is within one region's multiple zones. So we are just checking that. Okay, so yeah, availability zone is better than availability set. But availability set is if the company does not want to spend a lot of money. Availability zone is when the company wants its virtual machines copy to be across different zones. Okay, so the first machine is, we're gonna give it first zone just to check that zone redundancy there in the load balancer. If I go further down here, there is inbound port rules. So obviously we need it to be not only the RDP, and we need it to be that HTTP traffic as well. So I'm just gonna click the HTTP as well here. So the two types of traffics are there. In fact, it should be there with we can just create a new security group here, a network security group, and that goes in detail with all the you want inbound traffic to which port, and do you want to allow it from specific IP range. So a network security group just gives advanced features what we are doing here for inbound port traffic. Oh, you don't see RDP, Ahmed. This means that maybe you've not selected above the Linux Windows machine. I think it's a Linux machine, so that's why you're not seeing RDP. So change that to Windows 2016. If you go a little up, image. So Windows Server 2016 data center. So did you select that Windows? I'm creating a new virtual machine. So yes, you have to select the Windows machine, then RDP will come. With Linux, by default, Linux is selected and RDP does not come for Linux machines. Alright. So if we go down here, allow selected ports, and then yeah, we did not bring our license or our purchase license. We did not purchase this license for the Windows from any other source, and we don't need license now anyway, so we're gonna keep it no in that save money. And let's click the disks. So once we click disks here, nothing in that. Yes, we want a premium disk, which is okay. Then we go for networking. That's where we need to just check what's going on. So it already detects the VNet that I have created there, and then the subnet is also the one that I created, 10.1.0.0/24, and public IP. So that is also there. In public IP, we can actually go for create new in public IP. Let's click the create new because there are zone related configurations that we need to configure as well. I'm just going to click the create new in the public IP here. Once I click create new on, so now it is showing me the settings there. It is already on standard SKU, which is the load balancer configuration, and availability zones are only supported on standard SKU public IP address, yes. And assignment is static, but we want it to be zone redundant public IP. So okay, so I'll just drag that. The chat is actually coming. Okay, I'll just put it on my other monitor. So here it says availability zone. A zonal public IP is a guarantee to a specific zone and is tied to the health of that zone. A zone redundant public IP is served by all zones simultaneously and resilient to zone failure. For a single VM, you should align your public IP to the same zone as the VM. But so guys, what we are doing here is that we are putting that public IP zone redundant. If the virtual machine is in another zone, the other virtual machine that is communicating with this virtual machine is in another zone, they will still be able to communicate with each other easily with their public IPs. So if it is zone redundant, so the multiple zones can virtual machines can communicate with each other. So that's why we're creating public IP and then zone availability is zone redundant. So let's press OK. This is all being done to make sure that load balancer is able to reach that public IP across different zones, right? So and then once we are going for that, now let's just go for to create a new security group, NSG, a type of firewall under network security group, select advanced. And so I'm just going to go for advanced now, and we're going to create a new security group as well. So first we made the public IP zone redundant public IP, and did we do that? Did I do that actually? So if I click the create new and zone redundant, and then I pressed OK, right? Oh yeah, that was IP. Okay. And then second thing is I'm doing network security group here, and that is advanced. Then I'm going to create the new security group here. Once I click the new security group, so it is asking, hey, you want to make any changes to the security group, because we already defined the RDP port back there in the previous page. So what do you want to do with the security group? So we're creating new security group, and type my network security group and select really. So it doesn't ask me. Okay, there's that security group here already showing. So I'm just going to type here. It is actually starting with my name, so that is okay. Your first name, VM01-NSG, or it may not be related to just VM01. Maybe we can attach it to other VMs as well. So your first name, NSG, or network security group, right? And that's one thing here. And load balancing for place. So once you have created that RDP is there, I'm just gonna make sure and click that what else is allowed there. So there is 3389 here, and okay, I'll close that because we still need to have the HTTP traffic, right? So configure security group and create new. That's it. So we are supposed to actually go for network. I'm just going to press OK here, and that security group is already created, and it is this security group, right? Then if we go down, that's the main area where we need to work on, and that is load balancing. And I'm going to press yes here. In the load balancing, if I go down here, now I see or we see there's an application gateway, there's an Azure load balancer. Application gateway is an HTTPS web traffic load balancer with URL based routing, SSL termination, session persistence, and web application firewall, right? So learn more about application gateway. So this is all about if you have some complicated application there and you want to configure that. Suppose you have SharePoint there. Suppose you have Oracle is actually a database, but any web server or any hospital or insurance company application there. So you can just load balance the traffic for that application, and all the users will be load balance. So you will have multiple servers having each server having the same application configured the same way, and you can just go for all the features of load balancing to balance the traffic for that application. We're going for Azure Load Balancer supports all TCP, UDP, network traffic, port forwarding, and outbound flows. So first of all, it's not an application gateway. It is Azure Load Balancer. Then did we create already a load balancer? Yes, we did. So if we go for that, there's my load balancer here that I created. If we create that load balancer, then select a backend pool. So yes, I created the backend pool already. So this machine is becoming a part of that backend pool. So that is pretty much it for the network, this networking area of this virtual machine. So this is the same way we're going to create the second and third virtual machine, but we're going to make sure that the zone is different for that virtual machine. Zone 2 and then zone 3 for the third virtual machine, and accelerated networking is off right now because we're not expecting huge traffic there. And place this virtual machine behind an existing load balancing solution. Yes, existing. Yes, we have an existing, and we did exactly that. We placed it behind our just newly created load balancing solution. So once we're there, so I just wanted to make sure about this security group here, that what we have created, and it is already actually created, and we can later even pay it a visit and try to check that the ports that we have given, are they good enough, because we have already selected back there. If I click the basic here, so already we have HTTP and RDP ports there. But the load balancer would want to know what traffic are we going for. So if you go for advanced, now this is actually recommended by the document to create that network security group, right? So, and create new. So, and I did create new. I'm just gonna visit one more time here, create new, and it just is going for IP, and there's RDP port there, but I don't see here. So I'm just gonna click the add inbound port again for this. This is the security group that I created, or this is the name. I'm gonna click add an inbound rule, and the source is any. Source port range is any, and destination port range could be 80, not 8080. So I want the HTTP traffic, right? So, and then allow, and priority is yeah, 1010. Port name is HTTP add. So this security group is allowing the port 3389, which is RDP, and also allowing HTTP port 80. So I'm just gonna press OK here, and this is the one that we really need. Okay guys, so once networking is configured, load balancer has been configured for this first virtual machine. It has been configured on the first Azure as one zone there, availability zone number 1. So I'm going to click the management, and then there is nothing in the management. But the boot diagnostics, we don't need that to be turned on. So I'm just going to turn it off or keep it off. The boot diagnostics, I'm going to keep it off. And other than that, we're just going to click advanced, and there's nothing there. We talked about that last time as well, all these in detail. So I'm just going to click next tags here. We can just put suppose department is sales or branch is Toronto, whichever, and review plus create. I'm going to go there. Yeah, associating Jatinder, associating NSG to VNet is always better. So you can, if you want more options, then you go for network security group in AWS, Amazon Web Services. Normally, we always attach a security group there. SG there is called NSG here. It's the exact same thing. So if you want more options, and suppose you have multiple machines and they all must have the same configurations, then it is really important to create a NSG. Attach this NSG to, you can attach this network security group to 20,000 machines. One NSG, you can attach it to thousands of machines, one. But if you want different configurations, then you don't need to add NSG there. And NSG also lets you select that from where you want to accept the traffic and from where you don't want to accept the traffic. So or which IP range the traffic should be coming from, which public IP the traffic should be coming from, and what kind of traffic is there. So NSG, once you create, you can just reuse it for hundreds of virtual machines or thousands of virtual machines. So that's the benefit of that. Otherwise, you have to select each virtual machine type. You have to select the port yourself manually. And then yes, Ahmed, we already created the backend pool at the start of the class. And NSG is associated with subnets. No, NSG is, so subnets are associated with VNet, Jatinder, and so VNet and subnets are created. And once we create a VNet, we must create at least one subnet. We will be creating VNet in future labs, but NSG is always attached to virtual machines. NSG is always attached to virtual machines. And virtual machines are attached to VNet, which has subnets. So VNet and subnets are different. NSG and virtual machines are different. So NSG is all for virtual machines only. Okay, and duplicate. and opening. And if I type here, okay, and network, so it's already there, network security group, this one. If you go to search, and once you click add, so there is that resource group that it wants, and create a network security group. Okay, let's just give it 28, and then give it a name, test, and it is also going for ECOS, and tag, and review, and create. So the question is, please go to any NSG, and I'm just going to an NSG here, and then there is inbound rules and outbound rules there. Normally that is supposed to be the case. Network security group, oh okay, it was not created yet, so go to the resource, and that is, yes, that is NSG here. So there are inbound rules and there are outbound rules, and if you see that subnets are showing there, so it normally associates, NSG normally associates to the virtual machines in the subnet. So, and if you're saying that it can be attached to subnets, yes, for the virtual machine. Suppose you don't have any subnets, suppose you don't have any virtual machines there, then there is no need for NSG as well if you don't have any virtual machines in the subnet. So ultimately, when you're associating it to the subnet, you're associating it still to the virtual machines there in the subnet. Suppose you don't create a virtual machine there. Then first of all, why are we even creating NSGs if you're not creating virtual machines? But main problem, purpose of NSG would be to give or allow or block the traffic to the virtual machine. That would be the main thing. But when you create it and attach it to subnets, you're still attaching it for the virtual machines. If the virtual machines are not there, then you don't have to really attach that. So yes, you can, if you want to say that, yes, we can attach it to subnets. What it is for virtual machines. That still doesn't changes, right? The NSG is for virtual machines, but through subnets you want to attach it, or directly to the virtual machine you want to attach it, it's up to you. But they are for virtual machines. They are, if you attach it to a empty subnet, obviously there is no purpose of that. So that's what I am trying to say here. So yes, you can attach, but for virtual machines ultimately, and you can attach them directly to the virtual machine as well. Okay guys, so if we go down to these details here, right, if there are any questions, let me know. So let's click create. Once you click create here, so that NSG, we were creating a virtual machine, right? So virtual machine is getting created, and I'm just gonna create the second virtual machine and third virtual machine now. And well, it is being created, so we don't really have to see that or wait for that. So I'm just gonna go to the virtual machines here. While the first virtual machine is getting created, I'm gonna click the add button here. I'm gonna go for the second. I'm gonna make sure that it is in my resource group that is already created, and it is your first name dash VM02, and then it is in East US, and it is in availability zone 2. That's the main thing, because load balancer is zone redundant. Then I'm going for Windows 2016 here as well, and then there is your first name admin, username, and the password small abc capital ABC shift 123 and simple 123, and then small abc capital ABC shift 123 and simple 123. And then I don't need to actually select the allow selected ports here. Okay, so they're saying when we define VNet and add subnet, it has option of associating with NSG. Okay, NSG can be associated directly with virtual machines and with subnet, but if you attach NSG to subnet, then again, the virtual machines, ultimately it's going to still be attached to a virtual machine. So that NSG that you've attached to subnet will, when you're creating virtual machine, okay, yeah, the best practice would be that when best practice is define 10 or 15 NSGs there. Suppose one NSG is allowing RDP only, so you can name it RDP only NSG. Second would be HTTP, HTTPS, RDP. Third would be 1433 for database, right? 1433 port. So 1433 HTTP, HTTPS is there. So best practice is create multiple NSGs, then attach it directly to virtual machines or attach them to a subnet through the subnet to the virtual machine. So you can do all these yourself. Oh, that is actually application security group you're talking about. And application security group, okay, so that is actually in the network topic. We're supposed to talk about that, but since you put the question here now, so if we go for application, so there is security group. If I just type security application gateways, application inside, so you have to just first tell me that oh yeah, there you go. Oh, it is marketplace application security group, but it should be a feature inside the Azure itself as a service. So it's not a service first of all. If I start even typing, there's application gateway. Oh, there is actually, there is application security groups, right? So then second thing is that if I click the add button, so okay, I should not click the add button. First of all, normally security group is what? So security group is for in blocking and allowing inbound and outbound ports. So application security group will be doing the same thing for that particular application. Suppose it is application for 14 database. So obviously you want the database port and any of the port, any of the traffic to be allowed and disallowed. You will do that with application security group. But first, let's just read that no application security groups. So you can use application security groups to configure network security as natural extension of an application structure by arbitrarily grouping VMs and defining network security policies based on those groups. So you can reuse your security policies and scale without manual maintenance of explicit IP addresses. The platform handles the complexity of explicit IP addresses and multiple rule sets, so you can focus on your business logic. So it's just saying that application security group will still depend on the network security group policies there, which is saying here network security policies to allow or block traffic for the applications itself. So now if you have an application, then we can create it, but I'm just going to go through that because this question is there. So application security group and click add button to explore the features there. I'm just going to make it the same resource group name, and then name for that is your first name dash application security group, and then again let's just put it on the same region, US, and tags and review and create. So I just created before that I created a network security group. Now I'm creating an application security group. So definitely again it would be allowing and blocking ports, but on what level? So you have to attach it to an application and then allow and block ports according to that. But it is creating now. Once it is created, let's just explore it a little and then go ahead with our topic. Was there any, Jatinder, was there any question for application security group? Oh, okay. But that was not in the exam dump, right? Oh, okay. So yeah, the resource is created here. I'm just going to click the go to resource for application security group, and the policies I want to see application security group. Normally they say that if you have network security group, that this is just an extension to that. Now when you go for network security group, that had a lot of options there, but here when you're creating, I'm just going to refresh that, And application security group, overview, activity log, IAM, these are the common services, and lock. And so pretty much I don't see actually anything inside. So that just means that it has to be attached to an existing application, and it will be attached to the application and to the network security group. But we have to actually see some scenario there and then try to do that. So yes, example, and then add rule to low HTTPS. Oh, okay. So you're saying that okay. You want to go to the NSG. Okay, I hope it's not very long because we are on load balancing topic. I'll just check that once again, and network security group. So that there's the network security group, network security groups, and there's the NSG here. And what were you saying? Inbound ports. At destination, it asks for create inbound rule. Well, there is an inbound security rules here in a network security group, and then add and add inbound security rule, right? So yeah, well, add would not have it, so you want to create a rule. Okay. Destination pick ASD. Oh, okay. In the destination, add, and in the destination, there it is. Application security group, master G. So destination application security group, and then the application security group that we created there. But it's again, as it was saying. So if I go back here to the application security group and actually go to the, okay, let me just type it again. Application security groups here. So as it was saying in that explanation as well, that application security group is just an extension. So if you have an application and you want to connect some inbound outbound rules there, so NSG will not directly connect to an application because application does not recognize that, but it can connect to an application security group, and that application security group you can connect to any application if that application is compatible with Azure application security group. Yes, but application security group itself is not actually offering any options. It is still using the network security group, and that's a very good insight into this, Jatinder. Actually, I never did not try that, so thank you for that. But application security group is yeah, just an extension of network security group, as you have also just shown the audience here. So that's very good. Thank you. But it's we understand that it's not doing anything itself. It's still attaching that to the network security group, and we define everything inside network security group. But what is it? Yes, that's a good thing. You can just attach it to a VM after that. So when the NSG is attached, then you would be able to. Okay, you wanna well, okay. So if you have done that, so when you attach that, what are you then trying to achieve there, Jatinder? So NSG can be attached. Yes, we understand that. Oh, exam question. Okay, so that was an exam question there. So I have put the destination there. Oh, in fact, I want that load balancer lab to work also. So oh, there's HTTP. Okay, let me just, if my, if this lab is, oh yeah, there it is, port 8080 and port RDP. This is the one that I attached it to, port 80. Okay. And we create a new actually inbound rule, which is just showing this. Okay, so and then you are saying that just go to the virtual machine and attach it there. Okay, did I not create that machine? Okay, so that was an exam question, and you wanted this to be done. Did you do it that was a lab, Jatinder, or that was an exam question? So I'm just gonna pause now because we're not doing load balance. Well, what you have discussed here, very very useful. So definitely, I was not really paying that kind of attention to application security groups, but with your discussion, now it's even more clearer. Although that was not even coming in the load balancing lab, but since you put the question, so it's a very good discussion to understand ASG, how it really works. Thank you for that. So we can just go back to our configurations there, and I'm just going to go back to the second virtual machine. So we were just creating the second virtual machine according to that configuration, and I named it your first name VM02, then East US, and availability zone is 2, and image is 2016, and the username is this. So I'm not using the public inbound ports. I'm going to go for a network security group there, and I'm not using any license, so I'm just going to go for disks, and then disks, nothing in the disks. I'm going to go to networking now. There, the VNet that I created is showing there, the subnet that I created is showing there, and advanced, if you go to advanced here, then there is configure network security, and so I have created that NSG already, so I'm just gonna attach this NSG here has allowed the HTTP traffic as well as 3389 RDP traffic. So I don't need accelerated networking, so it's off, but I do need this machine to be in the backend pool of the load balancer. So if we create the load balancer here, there is load balancing options, application gateway. No, we want it to have Azure load balancer, but application gateway would be also then used to actually connect to some big application on the other side or any other Azure subscription. Then select a load balancer. We have only one load balancer here, and if we go down there, we have only one backend pool here. And if we go to management, and that's it. Make sure that boot diagnostic is off, nothing else. Advanced, nothing here in the advanced. Tags, nothing in the tags. Review plus create. So the second virtual machine is creating now, and then we have the third virtual machine that will be created here, and that is, I'm just gonna go quickly to that one as well. Virtual machine first is showing now, and I'm just gonna go for add again and add it to the same 28 October RSG, and virtual machine name would be your first name dash VM03, and then we go down up to East US, and there it is, availability zone. And in availability zone, this time we're going for zone number 3. So first machine is in zone 1, second is in zone 2, third is in zone 3, and image is Windows Server 2016, and then your first name admin, and then the password small abc capital C 123 and simple 123, small abc capital abc shift 123 and simple 123 here. And again the same drill. I'm not going to use the public inbound ports. I'm going to use the NSG, network security group, and nothing here. Disks, nothing in the disks. Networking, then I'll just go for public IP is okay. I'll go for NSG advanced here, and then go for the NSG that we have created, and then we go for load balancer here, and it's Azure load balancer, and then select a load balancer here, and then select the backend pool for that load balancer. Yep, it is already selected. Management, turn off the boot diagnostic, that's all here, and advanced, nothing here in the advanced. Tags, nothing. Review plus create. So the third virtual machine is getting created. It has been attached to the proper VNet, the proper load balancer, and the proper NSG. But how proper it is all, we're gonna know that now. So that third virtual machine is getting created. The two virtual machines are still getting created here. While this is going on, availability zone 2, 3, and then we can just add a security group rule there that is allowing HTTP, which actually we did already. inbound add source service tag. Okay, so they're going for service tag. So destination port ranges, protocol action priority 100, but we just went for port 80 and HTTP. We already allowed that. Now, so guys, we're going to now connect to the virtual machine, and we're going to install IAS there, and we're going to run a script here that will let us run. So the two virtual machines are there, and the third one is now connecting. So the next stage is that we need to run the IAS server, and I'm gonna be copying the scripts there to install the IAS first in the first virtual machine, and then I'm just going to configure that page with the second script. It will remove the default file, and the third script, it will just run it will create its own file with some message there. So I'm going to be showing you all that, and let's click the virtual machines. And I'm just going to go for the first virtual machine here. I need to connect to it, and I'll go to the connect, and there's RDP, download RDP file, and so it is Central Docs, Tech Docs, Azure, and yes, I already have a file with that name. Once it is downloaded, connect, admin, and we go for the password, small MC capital MC 123. It connects. Once it is connecting here, I'm going to start the second and third machine as well. And so the first machine is starting. It's going to take a little time to start. I'll just put it here, and then I'll go for the second machine now, and click connect here, download RDP file, VM02, go there, connect, okay, it's asking for, so username is this, password is this. Second virtual machine connecting now. Excuse me. Wow, it's taking time, taking the resources as well. So while the third is connecting, I'll go to the first one, and I'll open PowerShell here, and right click Windows PowerShell, and more. I'll go for run as administrator, and I will be running the script. Now guys, I have already, I'm just placing that file here just to show you that the script are here, and this document from which I'm grabbing the script and actually following all the steps of this document, which I already put you at the start of the class. So I'm just grabbing the script from there, and that document URL, I'm putting it here. This is the document that I'm following right now for RDP. But step by step it looks okay, but when you start doing that, it gets complicated. So that's why we're doing it here. Now I'm just gonna connect to that machine, which I guess I am connected to already. So here I'm just gonna right click, and okay, that was the URL of the that site, and it just copied that. I just am going for that first install IIS server role. So that is the first one. I'm just gonna right click here and send and execute that. So it's what it's doing is it's just installing the IIS or Internet Information Services or web server. It's installing that here in the first machine. If I go to the second, oh, second machine did not start actually. So I'll just convince it to get started as well. Oh, RDP for the second machine is this, and it was too slow. And again, I have to give, I think, now it is connected, the second one. So it's connecting, and I'll ask the first machine to be connected as well, third machine to be connected as well. Connect, download RDP, and save, connect. Okay, it's gonna take some time to connect the third one. Okay, it's asking for username, password. Yes. Okay, third one is also connecting. So I'll just drag these three machines here one by one, and that's the second machine here, and that's the third is already there. So first, so that's the first machine, and there is the second machine, and there's the third machine. So these are the three machines here, but what we are trying to see here, so other two are starting, but this first machine I have already installed the web server because the command says it is done, right? All three, well, with the Cloud Shell, we may be able to do that, because then you have to tell the script that because it's the public IP, you can turn off the firewall, you can remote into the PowerShell of all three. So initial configuration is much longer, and then you can achieve that. So you have to open PowerShell from your laptop, then connect to through PowerShell to the first machine's PowerShell, second machine's PowerShell, then third machine's PowerShell, and then run that script and give the path of all three machines the public IP, and then you can run it. So it is possible, obviously. It just takes you have to just do the initial work. Yes, if the template is there, that is the best. That if you have the IIS already installed there, wow, what else we need? So I'm just gonna go for the second commandlet here in PowerShell, and that is I'll just place it here. So I'll just copy that and go straight here, and this is the second one. Second one is removing that when you install IIS, so the IIS start.htm file is always there by default, and it that page, there is the web page that says welcome. So we have removed that with this file, and then we are adding another file that just says hello world from whatever the machine name is. It's gonna pick up that machine name. So if I just I've just added the third line here and just press enter, so it has already executed, but I need to check that what did it really do with my web page. So I'm in that machine, and so if I go to that folder structure here, I'm opening the yellow folder, and then I'm going to this PC, then I'm going to C drive, then I'm going to inetpub, I'm going to www.root, and there is that file that got changed here. So if I double click that file now, so it just is supposed to run in browser that this is hello world, this is server, whatever the server name is. I'm just gonna close that, close. So it says, this script says, hello world, this is hello world from your first name VM01. Whatever name I gave there, the script just picked up that name of the virtual machine and it has given that. So it is very crucial to have that web page to show which server is this, right? So when the load balancer we connect to, and it connects to this server, so it will load the first page automatically of this server, and the first page will show that which server we are connected to. So second server will say VM02, third server will say VM03, and when we keep on connecting to the load balancer and it keeps on changing the servers, so we will know, oh, now we are on VM02, oh, now we are on VM03, oh, now again we are on VM01. So this means the load balancer is working perfectly. So the first server, I have configured that already. I'm going to run that script on the second and third server as well. And I'm going to go down here to the second server, click that, open. I'll just make it bigger. And then I'll go to the PowerShell on the second machine as well. Go to the more here, run as administrator. And I'll just make it smaller so we could know that which server we're working on. This is done already. Now this is, I'm just running those scripts again, and it's all about matter of copy pasting. So first script is going to just right click, install Windows feature, and that is minus name web server minus include management tools. That just simply starts installation of the web server. So there will be that green line there collecting data. While it is doing that, I'm going to go to the third server here, and I'll open that web server here as well, PowerShell here as well. And then same Windows PowerShell, also it's installing the web server here as well. So when the web server is done installation of the web server is done, then I'm gonna run the second script, which will remove the basic file, the first file, the welcome file that is by default installed, and it will then I will run this third script that will change it to the file that I need it to be there. That just simply runs the script hello world and the name of our server. That is very crucial to have just to test the load balancer. So it is on 89%, this is on 69%, 70%, 72. $92. Okay, it's done on the first one. Yes, Jatinder, you're right. They won the Pentagon order from AWS. I mean, like from Pentagon order, and but the thing is, it was very political. They basically did not deserve it on technical grounds. But maybe they will reach the level of Amazon Web Services. But this is really a very big defeat for being considered a big defeat for AWS. But it's just that I think Trump hates the CEO of AWS. There is some problem with that, and it's totally political that Microsoft Azure won that. Yeah, but it's not very technical that on technical grounds. Yeah, it is more. It's all political. But Pentagon kind of institute should have AWS because AWS is much 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 more stable than Azure. They will learn it the hard way, I guess, and then they will go to the AWS. I think silently. So, yeah, AWS is much much more stable than Azure. And okay, I'm just running the second script here. Enter. I'm running the second script here. Enter. It's run. Then I'm running the second script has removed that file from the basic file, the welcome file that was installed by default. And the third script that I'm running now and run already has just put that file that just shows this hello world from this machine. So I'm just going to run this file on these three as well. I'm going to go to the second server just to prove that the three scripts that we ran actually worked. First, install the IIS server. Second, remove the basic file. Third, install the file that we needed. inetpub, www.root, IIS start, and this is supposed to show. So this is showing hello world from this machine number 2. So yes, that is good. And this is showing, I'll go here as well. Yep, it is also okay. So this is the third file. So now all three are ready. So hello world from VM01, VM02, VM03. Now all machines are pretty much ready, and their public IPs, the first machine's public IP is 40.90. It starts with that first two octets. 52.188, the second machine 52.188.224, and 52.188.195. So all three public IPs are there. So now the load balancer needs to know that actually we when we were creating the virtual machine, we already added them to the backend pool of the load balancer. So it should be there by now. So now is the time to actually test the load balancer. So that's that moment of truth, that if we go for the DNS of the load balancer and put it in the browser, and does it go to the first machine, the second machine, the third machine, or any one machine at any given time. So I'm going to go back to the load balancer page, and there's that load balancer page. I need to get that front end IP, which is this IP 52.224.189.146. And so if I go there and am able to copy that, so I'm just gonna put that IP on my laptop browser, and HTTP. It goes to the second machine. Woohoo! Yay! If I keep refreshing, refresh 1, refresh 2, sometimes it just takes a long time to change. Otherwise, I can go to the other browser and just refresh there, and it will just, it's still on VM2. And did you select session persistence? No, Jatinder, I did not select session persistence. Still, yeah, if it is the, oh, wow, Zaka, that's good. So yours changed from 1 to 2 right away. So I'm just gonna go to the other browser, and that is IE, and I'm gonna put that, yeah, it is on VM03. Wow, Zaka, that you're fast. You are somehow running low on memory. Do you have to replace computer name by VM0123? Ahmed, this is just to test the load balancer. Otherwise, we will have no idea if the load balancer is working. If the page is exactly the same, then we would not know, did it go to server 2, did it go to server 3, did it go to server 1. So now, yes, so that's why we must change that. Yes, just for the test. In a production environment, no, we don't have to change that. It has to be exactly the same application. In fact, it should be exactly the same application. Users must not know they're connected to actually third server or second server or the first server, but for our test we had to do that. So yes, on other browser, when I go, it is connecting to VM03. On this Google Chrome, when I go, it is VM02. So that is, wow, okay, that's good. So the load balancer really works, and that document that I sent you is one of those Microsoft labs that actually work. Like they have given it so good, and I tried some other documents, and there were some gaps there, and I had to fill it up with going to other forums and making the whole lab for us. But the load balancer, I wish they create all the other labs this way. That was pretty straightforward. So guys, this is load balancer, and we if you followed that lab, so that is very good. And now we can go to our other topics there. And other than load balancer, there is that storage accounts, and well, other than load balancer in the virtual machine. Okay, so there are some pictures coming from Zaka, and it's on WhatsApp. Okay, excellent, Zaka, excellent. Yeah, so it is VM02, VM03, and VM01. Hey, that's not fair. I mean, that's good. That's very good. I didn't get that, so that's why I'm saying not fair. But so very good, Zaka. I mean, you're seeing actually all three machines. Very good. The one we created now is public. Yeah. Yeah, so Jatinder is saying that internal load balancer. So Jatinder, you have to just create. In fact, that is public. So internal would be that within one VNet, you can create that. So suppose I go for a diagram here, and that is the traffic is also coming from the VNet. So suppose this is in the cloud you have VNet 1, and if you've already created VNets, then you will understand, because this is still an upcoming topic. So that is VNet 1, and then that is VNet 2. So now, and maybe you have VNets here. I don't know why I'm creating this shape, but it's just a virtual network, right? So VNet 3. So and that was actually 2. So if the virtual machines, a lot of virtual machines are here, and the traffic is actually coming from another of your private VNets, there are a lot of virtual machines, suppose here, and a lot of virtual machines here. You're expecting VNet 2 is expecting traffic from actually VNet 1 and VNet 3. So the traffic is hitting them, and they're all private networks within your Azure region here, right? So this is whole Azure East US. This is all East US. So the traffic is coming, and you have to, and they are all connecting to these web servers here. So, and they are only in VNet 2, suppose. So in that case, when the traffic is coming from this side, those users who are connecting to these virtual machines, and that virtual machine, from this virtual machine, they're trying to connect to that web server. Suppose there's a link there in the virtual machine in some application. They click that link. That link takes us to these web servers. So obviously then you have to put a load balancer, that is internal load balancer. Internal load balancers are that you have to define that the traffic, the source of traffic is which internal networks, and the destination is obviously the backend pool that is created there. So load balancer, and so it is just receiving traffic internally from within the region, from across the region, but within the Azure network it is receiving all the traffic, and from there it is divided among all others. You just have to define the source for the traffic as other VNets if you have created those. So that is internal. So not much difference between external and internal. Internal, you just have to have traffic coming from within another VNet, or it's not even other VNet, it could be the same VNet as well. So if SQL DB is active, if SQL DB is active, is primary and secondary. Okay, so we no, it's okay. I get that. Jatinder, we talked about that already. That when you select that elastic IP, it was, or yeah, it was floating IP. Yeah, we were talking about floating IP, and but what you're saying is if they're active passive. Normally, when you create, suppose there's a that VNet is there, VNet 2, suppose, and there is traffic is coming from VNet 3 here. So you have a load balancer, and the traffic is coming to this LB load balancer, right? Now there's a load balancer, and there's that web servers. So the users are connecting to the web servers in the backend. Suppose there's another VNet, and this VNet has all the database servers. So, and suppose there are two. It shouldn't be two, actually. It should be, suppose it's 4 or 5 database servers. Now normally what happens is, either you can make one active and all other passives, or you can make them active as well. So in that case, you have to have another LB here as well, and whatever the web servers are receiving the traffic. When the users connect to web server, they make changes there. So those changes have to be saved in the databases. So when they're making changes after connecting to that, those changes are redirected to another load balancer. Load balancer will distribute that traffic among other active active database servers. If you have active passive, then obviously you don't need a load balancer for the first server, right? If you have just one server, one SQL server, you don't need a load balancer then, right? You need a load balancer when there are equal configuration multiple servers there. They can be on different zones. So just like we created on different zone, because LB can be zone redundant, so they can be, and that's a very good configuration. They should be on different zones because LB supports zone redundancy, right? Redundancy here. So this means that they could be on different zones. So this would be zone 1, this would be zone 2, this would be zone 3. We just created that and it worked perfectly because we put them on definitely on 3 zones, and the traffic was redirected to all 3 zones. So yes, if you have active, then you need load balancer. If you have just one active and others are passive, then you don't need a load balancer. Obviously, when there is only one server, what would you load balance to? Load balancing only works with multiple servers. So if it is active passive, don't install load balancer. We don't need that. If it is active SQL servers that all are receiving traffic, all are making changes, and then they are synchronizing each other, then go for load balancer. Okay. Then there's a question there. If the DBs are active, they have to be in same zone. No, they should be in different zones if the company wanted to invest more. If they don't want to invest, or they don't want to pay for the multiple zones, then you can go for availability set feature. If they are on, if you want to go for different availability zone, that would be better. It will be a little higher cost, but the companies will have, if there is a zone level outage, the company will be okay. They have to be okay, but there could be network latency if they are in different zones. So Jatinder, normally Microsoft claims that network latency is being reduced between different zones within the same region. But yes, there will be some network latency. So it will not be a synchronous replication. So there is always two types of replications there: the synchronous replication, sync, and async, right? Asynchronous replication. Wow, that's a very bad writing. I'm writing with the mouse. So async replication. So obviously, when it goes to zone redundancy on zone level, it goes down to asynchronous. Asynchronous means that first the change happens here, then the change happens across the zone to the other. Synchronous means that the change is happening here and change is happening at the same time there as well. So there's no data loss in synchronous replication. There is a data loss in asynchronous. But Microsoft is claiming that within one zone, multiple data centers, if you want, then it is very less latency or no latency. So, but across the zone, yes, there will be latency. So you have to take into account all that as well when you're architecting that Azure solution for databases with load balancers in the background. Okay, and they are claiming that their MFA failed 2 weeks back. Yes, yes, Jatinder, that's the thing. I don't know why Pentagon had to go for that. Pentagon has to follow Trump, otherwise. So the thing is that Microsoft Azure had more outages, and AWS had very less outages. So they will learn the hard way that they should have gone for AWS. The thing is that. So now we're talking about, we've talked about NSG, we talked about application gateway, which is also, thanks to Jatinder. And then we talked about load balancer, we tested the load balancer, and then there's another comment: Bezos have to contribute more to Republicans. Yeah, well, actually, Bezos has, I think, Washington Post, he also owns that. And Washington Post is anti-Trump, and they have really revealed a lot about Trump. So it looks like that is the cause that Trump doesn't want AWS to get that contract. So, so it's purely political, and I'm sure they're gonna learn the hard way when there are outages occurring for the network. Pentagon will say, "Whoa, what have we done?" They have to go to AWS. So. Alright guys, so let's go ahead, and there is 9:21 here, and since the lab will keep on going till 12 o'clock, so we're gonna now start the storage account. and that storage account, we need to just create that storage account. There are blobs there, and blobs are not those Halloween like jelly like thing that just goes up to you and then eat you alive. We're not talking about those blobs. It is a binary large object is called blob, and that is just a storage. So but we're just talking about storage account. So let's just try to create one and understand, explore all the options of a storage account here. Let's click the add button here. Okay. Yeah, so it is 12 a.m. or 12:30 a.m. Zaga. So, and we must all sit in that lab because it's very important. Okay, I'm just kidding. Come on. So, okay. So here, so it will be, at 10 o'clock, I'll be running the first one. I'll be the first one to run. Hey, man, it's been a whole day. We're working. We need to sleep. So, anyway, so here, let's go to storage account and click add. So once you click add here, then there is resource group, and I'm just gonna click the resource group here, 28 October here, and then a storage account name. Now this is globally, has to be a globally unique name. We will be just type, and it has to be small case. So your first name, I hope it takes hyphens, and then storage account with all small case, and it also does not take hyphens. So backspace, yeah, and then we're sticking to some advanced features, so we need to go to ECUS, and so there is then comes the performance. So there's that standard, and standard offers you storage v2 or general purpose v2, which is SSD. It provides SSD. If we go down to that, there is storage general purpose v1, uh, and then there is blob storage. So and now storage general purpose is that you can have even virtual disks uploaded there. You can have files and folders uploaded there, and IOPS. It's all about IOPS and throughputs, that input output per second, and that is IOPS, that what you read and write on the disk, and then throughput is how fast the data reaches the disk there. So XST related to only blob. So access tier also is related to the premium version 2, but if you go to blob there, definitely that is where you can just select that RAGRS, LRS, and GRS itself, because it is offered there. Blob also offers that you can upload virtual disks, and there's a page blob and there's a block blob. So page blob is all about if you want huge amount of IOPS, and it is page blob and it is for virtual disks, and block blob is for files and folders. But yes, blob is for serious kind of availability, and large companies would go for blob storage there for their virtual machines mainly, or especially if they are having their critical data, they want it to be highly available. Otherwise, it is then general purpose storage, which is like files and folders you're uploading there. Now that is under the standard in terms of performance. Then if you go to premium here and we click the premium, so then you can see that storage general purpose v2 also has the LRS, and this is just LRS there. If we go for an LRS, is that locally redundant storage, which is just one zone. And if we go down to storage general purpose v1, then also there is just LRS here. And if we go to blob storage, block blob, so this is just block blob, and then there is just LRS there in premium. So it's local storage, right? And then file storage, basically when it goes to, then also it is. So the thing is that if you go for premium, and it is block blob is, remember, block blob is for files and folders, and page blob is for virtual disks there. Page blob is for virtual disk. So Premium offers that LRS locally redundant, but it does not still go for geo redundant or cross the region. So if we go for standard, and if we still stick to v2, it is still going to take us. So you can see here I'm putting the standard here, and it was on blob storage first, and it was showing the 3. If I go to storage v2, so it is still showing there replication, and that is showing pretty much all types of. In fact, there's a new one that is in preview, RAGZRS, or this is read access geozone redundant storage, and then there is geozone redundant storage. Both are in preview right now, and read access geo redundant storage, RAGRS, and the other ones. So we were seeing that we were not seeing that before for storage v2 here. We were seeing that when I just put the block storage here, and when I come back here, storage v2, it is there for that too, which is good. And then, so it is not related to just restricted to just blob storage. It is available in storage v2, or if I just, I don't want to refresh this page, because it was as you also saw that it was not there before storage v2, but it is loaded there. Maybe it was there, or I didn't notice that. But when I put the blob storage, then it appeared there, right? So if I go for storage general purpose v1, it is not there, but for general purpose v2, it is there, right? So, but account kind here, when we go for general purpose storage accounts, provide storage for blobs, files, tables, and queues in a unified account. Blob storage accounts are specialized for storing blob data and support choosing an access tier. So, which allows you to specify how frequently data in the account is accessed. Choose an access tier that matches your storage needs and optimize costs. So the thing is that you don't want to pay much. You can go for LRS, which is local redundant, and then there are all those versions for v2. We're going to talk about that in detail as well later. I'm just trying to create one storage account first of all. But a locally redundant storage, it's just one data center there. Then zone redundant storage, within one zone, one data, multiple data center within one zone, locally redundant. Then zone redundant, it's across the zones there. Geo redundant is that it's across the regions, one region to second region. Read access geo redundant is that it is one region. So let me just go for that diagram here, just to explain that. So suppose you have and that is exam question as well. So suppose you have here one region, and then you have here the second region. So now you have zones here. Suppose there is in one region you have one local one zone, and you have multiple zones here, and these zones you have virtual machines inside, right? So if you have these zones, and so if LRS is that you have one AZ availability zone here, and one AZ here, and one AZ here, and also there is, this is the region, right? So within that AZ, if you have one virtual machine here, so that is within that zone you may have multiple data centers, and so within one data center you have that virtual machine, that is LRS. You don't want to spend much. Okay, then it is LRS there. Okay, then I cannot click that now, because the whole screen is I can just do markering it. So the second one is zone redundant, which just means that your virtual machine, its copy of that virtual machine will be there also, zone redundant. So at least if there's a zone level outage there, then zone redundant, and there is zone level outage. Suppose this zone is gone, so this virtual machine's copy is here, but that's not a virtual machine. We're talking about data here right now. So it's data that will be available across the zone here. And then there is geo redundant. So and geo redundant and read only geo redundant is that if you have data and you want to have it copied across the region here. So from this region to this region, the data will be copied, but this will be the active region here, right? This will be the active, and this will be the passive version of that. So that is actually when we say passive, it is RAGRS, and RAGRS is that this is active copy of the data here, and I'll just change the color here, green. So this is the active copy here, and this is the passive copy, and that is we can say RAGRS. RAGRS is that read, access, and geo redundant, right? So a zone, but or sector or secure. Okay, so RAGRS, and now active is there and passive is there. So this means that there is asynchronous replication going on, asynchronous replication going on between the two. Obviously they cannot afford to have synchronous replication, which has no delay, but it will take down your WAN connection. And then second would be the GRS, which is that both areas have the read. This is active, suppose GRS is. So if you go for GRS, so the copy here will be active and the copy here will be active as well. So this means, and they are still going through asynchronous replication. But the thing is, if the clients can connect to this copy here with GRS, they can also connect to this copy here in for GRS as well. Suppose this is a zone you selected as Singapore, and the other zone is North, US East, so US. So in that case, so Singapore clients, if it was RAGRS, then Singapore clients have to actually connect from Singapore to this region, because that is the only active copy here. But when they create GRS here, so now Singapore clients can connect to their version copy without costing a lot of bandwidth, and the US users or North American users will connect to their copy in North American. So GRS would be both are active across the region. RAGRS is one is passive in one region, and it is just read only or standby copy, and the other is active, that is RAGRS. And then there is that zone redundant. So across the zone, within one region, across the zone, you have that copy here, and then there is that LRS, which is within one zone, within two data centers, you have the copy there. So these are all the types that we have: GRS, active across the region; RAGRS, active passive across the region; zone redundant within one region, two zones; and LRS within one zone, multiple data centers. So, and that would be cheapest, obviously, and that's why LRS is by default available here. So this video would you could just revise that in the video and by seeing the diagram, and also you have all of documentation. So if you go back here, so that is performance here, and then standard. We can make upgrade from standard to premium after the storage is created as well. But right now storage V2 would be the most useful one. But if you go for V1, so you don't have any kind of redundancy there or replication there, while V2 you have that redundancy there. So LRS there. Now then there is access tier as well. There's a cool tier, there's a hot tier, and then there's an archive. So cool tier and hot tier, what is the meaning of that? That is if you are so cool tier, hot tier, first of all, is that it is frequently used data, right? Frequently used data, frequently used data. So, and then there is frequently used data, then the that is hot. Then the cool one is the next tier, and that is used for archiving basically. Then that is non-frequently used data, right? Non-frequently. So, and then there is the third one, and that is archive, and that is not showing here, but obviously you can use that when you have paid for to have archive also available. Archive is for long-term backup, right? So now you pay more for frequently use, so long term. So for 7 years, for 10 years, for 20 years, you want to use that. So go for archive there as the type, right? So what we are saying here is that hot data would be frequently used, so we pay more for that, for pay for read and write. So we pay for reads and writes. So now for this it is reads and writes, and then that is frequently used and hot tier. Then comes the cool tier, and that's where you go for it is non-frequently used data, and that is you pay less. Payless actually, yeah, they went as well. They were very good. Okay, Payless for reads, and this is not frequently used, right? Pay less for reads, but pay more for writes. Whenever you want to actually, it is read it, when you retrieve that file, which is actually read. So pay less for. Okay, let me just make it correct. Pay less for keeping the data there. Pay less for you want to keep the data, but nobody's using that, right? In hot tier, which is the default, everyone is using the data frequently right now, so they are charging both read and write. But when you so you say that after 30 days you've seen that, you've researched it, suppose that after 30 days whatever file is uploaded here is not being used a lot, so why we are paying more for the file that we are not using? So why don't we move that file to the cool tier? So when you move the file to the cool tier, so what happens is that for keeping that file there while it is not being used, you pay less, but pay more when you are actually retrieving the file. Retrieval fee is more because they have to pay their bills as well. So pay more for retrieval. That's where they then earn that money. So obviously when you're paying very less for keeping the file there, they have to charge you when you really need that file after quite some time, right? So pay more for retrieval, and so that is cool tier. But it is less expensive to keep the files there while you're not using that. Whenever you use that, then they charge you a little more for that. And long-term backup, pay very less for keeping. So pay very less for keeping the file. So for file storage, for keeping the file, keep files, and but then pay more for retrieval here as well. So obviously then they have to really charge you, pay more for retrieval. And with archive, the SLA is 4 hours when you are retrieving the file, right? RATREVAL. I'm improving with my mouse writing. So okay, here, so pay retrieval fees is more. With archive, retrieval fee is a bit less, non-frequent, and read and write fee is a bit more when it is hot data or frequently used data. So but with archive there are tricks there, like not tricks exactly. With archive, the thing is that SLA with archive is SLA is 4 hours. For the free tier it is actually 24 hours. So what is SLA 4 hours? As soon as you double click the file in archive, it's not going to be opened for you. It will take 4 hours for it to open for you, right? They will retrieve it from the archive, and then the file will be opened for you. Suppose you want the file right then and there, then you pay more. But when you put in an archive, that's the main thing. You're saving the cost there. You're keeping the data for very long term, and whenever you retrieve, they will charge you. If you want that file as soon as you double click, you just pay more. Otherwise you don't want to pay more for retrieval, and it's not that important to have that file right away then and there. So then in 4 hours you will retrieve that file. So there are different timings there, they just put those there. So if you need better service, pay more, otherwise it is there and you're saving your costs. So this is for, so hot tier is that frequently used data is, you have to pay read and write a lot, or more, not a lot. And then cool is that it is non-frequently used traffic, you pay less for keeping that data, but you pay more for whenever you want to retrieve. And then there is that archive, and that is you have to upgrade your subscription, so then archive will also be available, and you pay very less for keeping the files, but you pay more for actual retrieval. And whenever you retrieve that, if you want to retrieve it right away then and there, you want to use the file, pay more little, or otherwise SLA is 4 hours, or service level agreement is 4 hours. So that is so we talked about replication, LRS, zone redundant, so and locally redundant, then zone redundant, then GRS, and then RAGRS, which are geo redundant or across the region. Then we talked about the access tier as well, and that is hot and cool and archive, the three types there. So if we go ahead, so hot is by default, obviously when you create a new storage you have to then use that too, you will have to. So I'm going to go to networking, and in the networking you can connect to your storage account either publicly via public IP address, or service endpoints, which is any of your servers or from any specific branch, or privately using a private endpoint, which is you can just VPN to that as well. So public endpoint is okay, and all others will be able to access this storage account, which is okay. uh, or if you go for second option here, public endpoint select networks, only the selected network will be able to access the storage. And so this means that you can create a virtual network of VNet, and that VNet will, through that VNet the users will be able to access the storage. And private endpoint is create a private endpoint to allow private connection to this resource. Additional private endpoint connections can be created within the storage account or private link center. And they are talking about, if I click the add button for the private endpoint, that would be name storage resource hub, and it is location is still US East, and network, so which VNet are and which machine in which VNet it is coming from. So virtual network, if we drop down here, that's only the source is still the virtual network, because private endpoint is again whatever your machine is in any other private VNet that you have, you want to connect from that. So I'm just gonna stick to the public endpoint, all networks there, and then click advanced here. And then there is secure transfer required enabled, obviously, so it will be encrypted, your data will be encrypted there. And it's wow, it's actually hidden there. Cool, that's new for me. So here normally what they're saying is that the data will be transferred over HTTPS. That's pretty much what they're saying. SMB, server message block, is for if you have Windows machines connecting to each other and they are sharing files with each other, they use SMB protocol, or CIFS or CIFS as well. Linux, they can also use Samba to connect Linux to Windows, but normally this is just the way they SMTP, SMP port, no SMB, that would be SMB port. So server message block port, so Windows SMB port, and that would be, as you said, 445 exactly. So but there is port 139 there as well, and but yes, that is 445. Oh, exam question, man, you're good. Jatinder, you're really, wow, very good. So exam, and you remember all the exam questions still till now. It's been 1 week. Normally we forget in the next hour of the exam, so that's very good. So secure transfer required, so it will be obviously encrypted traffic. HTTPS is involved there. Then there is Azure Files or large file shares, provides file share support up to maximum of 100 terabyte. Large file share storage accounts do not have the ability to convert to geo-redundant storage offerings, and upgrade is permanent. So the thing is that when you are going for large files, and that is gigabytes or terabytes of files there that you're transferring, so in that case you can't have those file with cross-regional replication with geo-redundant, which is that both are active. So you cannot have that replication enabled. So if we Azure file is there, if I click the enable button here, so it says here large files share storage do not have the ability to convert to geo redundant storage. Anyway, so if there are very large files that you want a copy of those across the region, you can only have RAGRS, read access. So this means that it will be a passive copy of those large files in the other region. So that's what they are offering for now. Data protection, blob soft delete, and that is very good. When turned on, soft delete enables you to save and recover your blob data in many cases where blobs or blob snapshots are deleted. This protection extends to blobs that are deleted as a result of overwrites. So the thing is that soft delete is it's not a hard delete. Hard delete is permanently deleted. Soft delete is a recoverable delete. Files are recoverable, right? So they're just saying that. But if we enable that soft delete option there, so then they say that for how long do you want that deleted items to be still there waiting to be recovered? So, and if you expand that, so it will be 1 year, they can keep that. They're going to charge you a little more, but they can keep your deleted items in that deleted files in the storage account for 1 year maximum, and minimum is actually they had 7 days here, I guess. Yeah, so 7 days there, they are by default if you enable that. So minimum is 7 days. Otherwise, it is 1 year maximum. But you can recover the files. File recoverability is very good option. You should pay. You could when you're doing that, get approval from the boss and check that how much it will cost you, and then do enable the soft delete option, so you could recover some files for certain days. It will be retained there. So data lake storage gen 2 generation 2 hierarchical namespace. The ADLS generation 2 hierarchical namespace accelerates big data analytics workloads and enables file level access control lists. So access control list. So first of all, data lake storage, if I click the learn more here, then it is you can see that Azure Data Lake Storage Generation 2 is a highly scalable and cost-effective data lake solution for big data analytics. It combines the power of a high-performance file system with massive scale and economy to help you speed your time to insight. Data Lake Storage Gen 2 extends Azure Blob Storage. So what it says in English is that if you have huge data and you want to run analysis on that data, suppose you have a huge data about the sales you have done in last Power BI exactly. So business intelligence BI is available on Azure as well. Data lake is that suppose you have huge data for the last year. Suppose you have branches across the globe and you want to know that which branches had done a lot of sale, which branches did not do a lot of sale there. So that's a huge data coming from Asia, from suppose Middle East, from Europe, from Australia. So you want to run analysis that which product in Australia sold more, which product in Asia sold more, and how much of that, what type of people purchased it. So you can actually build some new strategies, business strategies for the next year to launch some sales in those areas where the product was sold less, and attract those as well. So data lake storage would just collect all your huge data and then would let you run analytical applications there to give you all kind of research outputs there, that what if we have done that, or how much of this was sold in that area with that kind of features. So it will give you very detailed insight into or analysis into your data from your data, right? So this is just data lake storage generation 2. So it is if we click enabled, so the above option of data protection is not available. It's a huge data, but I'm just gonna click disable here. Then if we go for next tags here, nothing in the tags, you can just put a department as sales, branch as whatever. Next, and review plus create. Now this we have discussed actually the replication and access tier and account kind, and then storage account model here, especially account kind is storage version 2. So and then some connectivity methods there, but I'm not going to create now that account because I have to delete just now. So and it's going to take time, and it's 9:52 already. So I'm just going to cancel out from here because we wanted to explore the features. But in next class, we're going to be creating that storage account again, and that time where I'm going to go fast and create that storage account because we already discussed about all these features. And then once the storage account is created, we're going to check all the extra features that are coming with the storage account and the possibilities of upgrades there to next versions. So I'm just going to close that out, and it is 9:52. So if there are any questions, let me know, guys. Otherwise, if you've created all these labs, go to your left side and click the resource groups. If you have were following and you created that storage account, let just wait it to be created, because you added, I hope you added it to the same resource group. So if you create the storage account before me, so then just go to the resource group here on the left side, select that resource group here, and in fact that go to the today's resource group, and it has a lot of stuff here because it shows here how much we have created there: virtual machines, virtual NICs, and network security groups there, public IPs, even application gateway. So and then I'm just going to delete the whole thing. So delete resource group, and it should delete everything we created today and attached to this resource group. The good thing is we must have attached everything to that, then only we can, otherwise you have to separately go there and delete that. So delete, and it should be deleting everything. If we are, so there's a question there from Ahmed, if we are using a free trial version, still do we need to delete the resource group? Oh yes. So Ahmed, we have like if you have a trial version, you have $260 worth of services to explore. If you keep it like that, they will keep on minusing it from the $260 they have credited towards your account. So once those $260 are done, then they will start charging you, right? So either within 30 days $260 are done, or if it is 30 days past, any one of those. Yeah, in 30 days all gone. Yeah, yeah. So use up this $260 to create VNets, to create a lot of virtual machines, play with all the services there, and once either $260 finishes first or the 30 days finishes first, it will then be charged after that. So I'm on pay as you go for last 4 years, so it's the same account I'm using, and the thing is just delete it right away. So within hours delete it. So 255 remaining, a lot to go. Yeah, Ahmed, so you have huge, this is huge because all these services that we are using, they cost in cents. So even in 2 hours or 3 hours they don't accumulate much, and by the end of 30 days normally the students still have $200, and then they think that, oh man, I should have used more. So yes, go create machines, go create networks, and really crazily use that because $255 is too much. It's not finishing soon. Yeah, below wanna be super rich. Exactly. So exactly. So below is Bill Gates. Yeah. Okay. So okay. So here, okay, guys, that's it. 9:56, and see you next time. But that was a very good discussion. Thank you, sir, and thank you for all your questions. And keep those questions coming. We really enjoy that, and we really learn a lot from those questions. So please do come at 6:55 sharp, so we could start early and cover more topics and more questions. So that would be very interesting. Thank you, sir. Thank you, everyone, and see you next. Yes, Jatinder, you're the dude. So yeah. So and and yes, any question will be very very welcome. Alright guys, so this is deleting it. So okay, so I'll just stop the video and